Dear colleagues, let me introduce myself. My name is Puliaieva. My co-authors are Tatyana Zaytseva and Lyudmila Kravtsova. The topic of my presentation is choice of ship management strategy based on one-way forecasting. My talk will be in several parts. Main questions you can see in the current slide. Curriculum of Information Technologies based on competent approach to marine specialist training provides not only mastering the one or other discipline, but also able to use the obtained knowledge in the professional activity. Our research focuses on such an important question as the choice of ship management strategy based on the natural phenomena forecasting that conducted on the results of statistical observation on environment behavior which surrounds a ship. Science-type solution of analysis and forecasting is related with the usage of mathematical apparatus. Studying within all the discipline information technologies using possibilities of spreadsheet is supported by mathematical methods of construction of regression equations, solution of algebraic equation systems, and in more difficult cases, solution of differential equation system in partial derivatives. The modern development of information technologies and the power of software allow filling the education material with applied, professionally oriented tasks. The use of mathematical modeling apparatus allows students to be able to solve such tasks. Systematic study of research results of water resources behavior, weather conditions, natural phenomena, recorded in the form of statistic data, contributed to the development of the methodological basis of analysis and forecasting processes. Forecasting of natural phenomena is an integral part of the scientific approach to management decision. Our study focuses on the one-off discipline chapter, data analysis and forecasting, an example of mathematical modeling of the phenomena forecasting connected with professional marine activity based on results of statistical observations of the water environment behavior. Hydro-meteorological stations are the main source of statistical data. The use of modern computer technologies makes it possible to automate the process of collection, transmission, processing, and storage of this data. Unnatural hydrometeorological conditions are particularly dangerous and scientifically interested. These conditions include the following: irregular sea level variation, tsunamis, wave height is 8 meters or more in the oceans, and wave height in the sea that are dangerous for navigation, fishing, and coastal installations. Tropical storms and typhoons when wind speed is 35 meters per second and more. The appearance of the ice core at an unusually early date. The pressure drift of floating ice. Ship icing. Strong ebb tide in the port waters. Hydrometeorological condition forecasting provides a scientific evidence system, development of different hypotheses, and using methods that are characterized by mathematical formalization. Methods of probability theory, mathematical statistics, factor and spectral analysis, differential equations that describe physical processes are most commonly used as the mathematical apparatus in marine hydrologic prediction. So, two main directions are considered in the development of marine forecasting techniques: physico-statistical and hydrodynamic. In our work, we have considered statistical method forecasting, which provide an opportunity to evaluate the development of hydrometeorological processes in the future, based on the result of past observations using knowledge of probability characteristics of these processes. At the first stage of study, a general patterns between phenomena are identified and main factors are determined. In the second phase of forecast methodology development, the general physical regularity that was previously identified applies to specific physical and geographical sea conditions. For this purpose, observational data that needed to develop all the method are carefully analyzed for representativeness and comparability of observation in different years. A third stage is start of receiving predictive quantitative dependencies. Graphical comparison of predicted element with predictors should be considered as a visual way for finding connections. Next stage is the choice of the most adequate mathematical apparatus, which would allow the best approach to the problem, I mean creation of a reliable forecast method. Students of Kherson State Maritime Academy learn discipline information technology in the first year. It is clear that the first year student hasn't sufficient mathematical knowledge to comprehend the essence of difficult differential equations. However, understand of analysis and forecast significance, main method for their solving, possibility using in the professional navigation workload, quite an capable task. Therefore, task before teacher is to systematize them knowledge, increase level of understanding mathematical formulas, recognition them not as just picture, but as just instruction for action that result in strategy to ship and crew management. And thanks to the applied aspect of mathematical models, student interest to natural science disciplines can be increased. Consider a typical task of wave height forecasting dependent on wind speed and the duration of its effects. Using those information about actual and expected conditions of wave swell helps to successfully navigate the most profitable routes, effective and safe fishing, sea loading, etc. Determine main elements of wind wave for solving task: height, period, length, phase speed, steepness, right length. Table date 1 are the basis material of parameters for analysis and making forecasts. The task is to determine the type and dependence parameters of the wave height on the wind duration. The scatter chart that was created allows to make conclusion that in the wind duration from 5 to 15 hours, the dependence can be approximated by a linear function. In the wind duration from 20 to 50 hours, the dependence will be probably quadratic. Students are proposed to find the dependence parameters which are relevant and evaluate average squared deviation for each of obtained analytic relationships. We will illustrate the finding of linear dependence parameters applying Cramer's formulas and Excel built-in function and Excel features, like in this task, adding a trend line, displaying equation and R-squares value on chart. Applying the obtained equations, analytical dependencies, it is possible to make a wave height forecast for any wind duration and actually any wind speed. An expert review of the proposed material was conducted to support experience of teaching data analysis and forecasting of the course information technologies. An example of math modeling of wave height forecasting is dependent on some natural factors and also accuracy of the built model to the real conditions. For it, the method of expert estimations or Delphi method has been used. This method is the following. Expert group was requested to review the work, evaluate its professional direction, reply to the questionnaire and draw conclusions about actually of the proposed study and the practical application of the obtained results. A group that involved the work was consisted of marine industry specialists, chief officers and sea captains who work in academia or undergo retraining and has great experience on the ships. The 12 persons were invited for expert evaluation in a total. The expert questionnaire consisted of 16 questions. A quality indicator is a number parameter which determines the evaluation of the method according to its qualitative characteristics. Like a 5-point system was used for this. The expert evaluation of method efficiency will only be reliable if expert responses are agreed, and concordance method was used for this purpose. Using questionnaire data, the summary and matrix has been compiled. We have calculated the person matching criterion to evaluate the significance of concordance coefficient. The expert conclusion confirmed the practical significance of the results obtained in the work and practicability of their use for further research by results of calculations. Let's sum up. The aim of the discipline information technologies is studying of the mathematical or computer modeling methods, its application in various subject areas, as well as ability to predict and analyze the results of obtained decisions. In the use of information technologies, students practice skills of development of information models, solution algorithm, evaluation of obtained results. They feel a qualitative new socially significant level of competence, develop professional qualities of a person.